Okay, even though this says pre-calculus, this is not your lesson right here. Here we go. Inverse relations. Two relations, write this down. Two relations are inverse relations if and only if one relation contains the element b, comma a, whenever the other relation contains the element a, comma words. An inverse happens when you do what? What do you mean flip it? You switch the x and the y coordinates, right? That's what you do. We're going to write that down in just a second.
2, 1 and 1, 2 are inverse, right?
Yep, they're inverse points. Okay, so if I had a function that said x, y, I was given the point, and those 3 points were the points of my function. That was it. Okay, what would that's what the inverse. Okay. Okay, now here's the notation for inverses. F of x denotes a function. Then f with that little negative 1x denotes the inverse of f of x. I don't know why, you guys, but some time ago, some mathematician, probably 200 or 300 years ago, came up with the idea that we were going to give a symbol for inverses with this little f to the negative 1 thing. And it looks like an exponent, but it's not. And the reason I don't think it's a very good idea to show inverses that way is because it looks like an exponent. And sometimes you guys get them confused. But it's not. This is the symbol for inverses. I want everybody to say it. F inverse of x. That's how you read it. When you see that, it says F inverse of x. Okay, say it one more time. F inverse of x. Okay. Now, one thing you need to know is the inverse may not always be a function. Yeah, just write them down as I go down. So I'm going down one at a time so you can. The inverse may not always be a function. I'm going to show you some examples of some inverses. In fact, well, let's do it right now. Okay, if you guys were looking up at this parent function right here, you guys know how to tell whether a function is a function, right? What's the test we use to see if a function's a function? The vertical line test, okay? So I'm going to go right here. Test functions. Which is the vertical line test. Okay? Now, if you look at all these up here, they're all functions, the parent functions, but not all these functions have an inverse. Because what happens when you guys take the inverse of a function, it turns it sideways. And I want you to think, which of those, if you turned them sideways, would not have an inverse? Would not pass the vertical line test? The what? Okay, all the trig functions wouldn't. And we're going to talk about those later. So none of the trig functions would work because if I took line test, remember the vertical line test says that if a vertical line passes through the graph in more than one point, then it is not a function, okay? What did you say, Noah? Yeah. If you take a quadratic, which graphs a parabola, and you found the inverse, it turns it sideways, like I said. You turn that one sideways, would it now pass the vertical line test? No. Okay? So a quadratic, you restrict the domain, and that's what we're going to learn at the end. Notice that one of our a circle is, if you look at a circle, it's not a function in the first place. It doesn't pass the vertical line test. So a cubic is, because a regular cubic like this is, because no matter where you put a vertical line, it's going to only pass through it once. However, some cubics do this. And if they do that and you turn it sideways, it's no longer going to pass the vertical line test. How about the quadratics? I mean, not the quadratics. How about the absolute value? Well, sideways now it goes like this. Right? No, I mean, these are all functions, but their inverses are not functions. Okay? Does that make sense? All right, now, you guys, we have a test. Another line. Like, if you had a line like this and it turned 90 degrees, it's going to be going like this now. A linear function. All linear functions except for vertical. I mean, because a vertical line is not a function. Huh? I'll show you why in just a second. We're going to graph one here in just a second. Okay, I want to show you the horizontal line test. Write this down. To see if what? Yeah. You guys, you can test using the horizontal line test to see if a function has an inverse. Like, I already know parabola. If I do a horizontal line test, that means if I can make a horizontal line pass through the function more than once, then its inverse is not a function. Okay? So a parabola doesn't work. Neither does an absolute value. Neither do some cubic functions. If you start adding things to cubic functions and you did that, all of a sudden it wouldn't pass the horizontal line test. So you got to test on different kinds of functions to see if they're going to pass the horizontal line test. If they don't pass the horizontal line test, then they are not they're inverse. Got it? Okay, now we're going to practice graphing one right here. We are give you following points. And let's say I connected them like this. I want you guys to graph the inverse of that. What would you do? Exact. Right here. Comma 6. How about this one? Huh? 1 comma 7 and 3 comma 10. Now, to graph the inverse, I just need to do what? Switch the x and y. Instead of negative 5 comma 2, what am I going to have? 2 comma 1, 2, 3, 4, 5. Negative 3 comma 6 will become what? 1, 2, 3, 4, 5, 6. What did you ask? That's a good question. Okay, 1 comma 7 is 7 comma 1. And 3 comma 10 is 10 comma 3. So now we have this function right here. The rotations were a little bit different. You can use this as a rotation. No. Those are geometric transformations, what you were doing last year. This year we're doing algebraic transformations. We're doing inverses. By the way, you guys, is there any symmetry to this? Show me with your hand. Where is the symmetry? Yeah. Well, some of you guys got it. It's right here, y equals x. Who said that? Tyson, good job. Yeah. It's pretty good, huh? That's what happens when you're a math teacher. You practice a lot. All right. Okay, now, you guys, this line y equals x right here is this is what these two reflect over. Do you see that? Okay? That's what it reflects over. By the way, is my original one a function? And is its inverse a function? Yeah. This one passes the vertical and horizontal line test, and this one passes vertical and horizontal line test. Okay. So how many of you know how to graph an inverse? And I just wanted to show you that, even though it's really not part of the... No. No. Quit asking me. Okay.
Yeah, can I check on
Hey,
there where inverse function?
didn't I ever tell you guys the story of my brother-in-law? Oh, I'm going to tell you the story of my brother-in-law right now. I'm going to turn this off. Okay, now, guys, we need to know how to do is we need to be able to find the inverse if it exists. We're going to kind of that x equals minus 6. F of x equals 2x minus 6. We have got to find the inverse of this. Well, first of all, what kind of function is this, you guys? Linear. And it's not a vertical line, right? Because vertical lines look like something like x equals 2. So y equals 2x minus 6. So we know that all lines pass the vertical and horizontal line test. So this one does have an inverse. This is how you step on. You're going to take this f of x, and you're going to change y equals 2x minus 6. Wait. Let me ask you this first. What kind of question is this? All right, I can do that. That's step one. But you guys got to really pay attention. No, you got to write this down. Y equals 2x minus 6. Now, how do you find an inverse? We talked about this. Say that again, JD. Switch the x and y. That's right. That's step number 2. Okay? We've actually found the inverse now, but to graph it, what do we have to do? Yeah, we have to solve for y. So the next thing we're going to do is solve for y. So if I'm going to solve this for y, what's the first step? Well, first thing is to add 6 to both sides, right? Sorry. Add 6 to both sides. I'm going to get x plus 6 equals 2y. And then divide by 2. Cancel out. And 1 half x plus 3 if you divide the 2 in each term. Okay? 1 half x plus 3. Okay? So y equals 1 half x plus 3. Last step. Change y inverse notation. In x, you guys. right there, that right there is how you find the inverse of a function. Okay? How many of you guys that got that down? Can you do that? Okay. We're going to do another one. Okay, hurry. Write it down. Okay, we're going to do another one. This, you guys. Okay, this one, you guys, is a rational function. These are a lot more difficult. Okay. If I'm going to do this one right here, we're going to follow the same steps. To y first. Okay. Which solve for y. Now this time we have two y's, right? No, they actually don't. Okay. Because they're not multiplying, so they don't cancel each other out. So, okay. So what we do is we have to times both sides by y minus 3 to get the y minus 3 out of the denominator. Times both sides by y minus 3. We're going to y plus 2. We need to get the x and the y on the same side. So we are going to minus this y to both sides and add the 3x to both sides. So now we have xy minus y equals 3x plus 2. All I did is I added 3x. Guys. All right. Okay. Add 3x to both sides and I minus. So xy minus y is xy minus y. No, I factor y. So we can get 1y. Y. Got that? And I divide. Okay? Say that again. Change it to inverse notation. Inverse of x. 3 for x minus 1. Change it to inverse notation. That's it. If you graph those, you would see that those are inverses of one another. Okay? All right, I'm going to show you one more problem. Actually, two more. If you guys need to go back and watch the video of this to get the explanation, you can do it. Say that again, Zach. No, you don't need the graphing calculator. We're not going to really be graphing. That's just to check if you want to check to see if it's a reflection over the line y equals x, see if you did it right. Yeah, I want you to graph those. Yeah. Yeah. Hey, you guys, this one right here. This one I already put in y form instead of f of x form. I'm going to switch in y. I minus for both. I divide by 2. What's the last thing I do to get y by itself, you guys? This is the part I wanted to show you. Cube root. Cube root it. You guys. Okay. I equals cube root f minus 6. Okay? And that's the inverse. And you can put it in inverse notation by putting f inverse and write f inverse of x equals the cube root of 1 half x minus 6. Okay, any questions there? Okay, now the only thing we haven't covered yet, guys, is understand how to restrict the domain of a quadratic function so that it has an inverse. I want you to look at this right here. Okay? I want you to look at this. If you graph a parabola and the vertex is at 3, 2, does this pass the horizontal line test? Okay, no, because if you draw a horizontal line right here, it's going to cross it more than one time, right? So it does not have an inverse. It does not have an inverse. So what we do is we have to restrict the domain. Where can we cut the domain at so that it would have an inverse? Right at 3, right here, right down the middle, right there. Because now we're only going to have that part. And remember, you guys, what a square root function is the inverse of a square function. And it goes like that. Do you recognize that now? And so that's why square root functions are only half of a parabola turned sideways. Okay? So when we graph this one, the domain is only good from x is greater than or equal to 3. In other words, from 3 to the right is the only way we're going to restrict the domain to there so that we can graph it. I'll talk about that more next time. Hold on. Okay, you guys, I've got an assignment for you.